Want to welcome everybody to APC Packaging Sustainability Webinar. If you have any questions during the webinar, feel free to type them into the chat, and the moderator will log any and all questions. At the end of the presentation, I'll try to answer as many as I can. The polls are just for fun, and we're not going to tell who answered what, but we'll show what people did vote for. So the first poll question is, are sustainability and climate change basically the same? It looks like a lot of people have already answered that. So we'll go to the second question, which is, which of these materials is more sustainable than others? I'll give you guys 10, 15 seconds to go ahead and click on what you think is the most sustainable, and we'll move on from there. All right. I appreciate everybody polling. It looks like there's still a few people clicking on it. And all right, we'll call it and end with this. So once again, hello everybody. I'm Robert Bulla, and I'm a plastics engineer. I want to take a minute and tell you about myself. I've been in the plastics industry for all of my professional career, and I've been involved in projects from several different industries, such as medical, automotive, military, and now packaging. Throughout my career, I've experienced a lot of ebbs and tides of the green movement. As I began compiling my research, I wanted people to come along with me on a journey, and I realized, and it became very apparent to me, that I have to be utterly fair, balanced, and honest when it comes to all of the different topics we're going to talk about. Therefore, I've done my best to ensure the information present is factual, honest, based on research and industry experience, and our goal is to help educate people and brands so they can achieve either their first attempt at a more sustainable package or expand their portfolio of sustainable options. It's a habit of mine to look up the definition of a word or a group of words to ensure myself of direction. How many times have we thought we knew something and come to find out we misunderstood completely due to a single word or phrase? Here's Webster's definition of the word sustainability. Capable of being sustained, of relating to or being a method of harvesting or using a resource so that that resource is not depleted or permanently damaged, of or relating to a lifestyle involving the use of sustainable methods. So now that we understand what the word sustainability means, let's look at the four topics we're going to talk about mainly when it comes to materials: glass, plastic, biopolymers, and paper. What is the resource we need to protect and replenish in order to promote this sustainability? Well, with glass, the main component is silica. Paper, cellulose fiber, bioplastics, plants, plant extracts, and petroleum and natural gas. Plastic, petroleum, and natural gas. Sustainability seems like it wouldn't be that hard to do, and you may wonder why we didn't do this before. As an example, have you ever decided it was time to stop eating GMO or go all organic? If you have, you'll notice your grocery store bill will increase by about 30%. Why is it so expensive to grow plants organically versus how we do it now? I'm not going to get into why, but the example question shows you why it's not such a simple answer. This in turn presents another question. With all the recent growth and demand in sustainability and eco-conscious packaging from both brands and consumers, are these efforts going to solve the environmental crisis? be honest, the short answer is no, not at all. It's a step in the right direction and hopefully will bring about change. Fixing our global sustainability problem will require substantial efforts at the macro and micro level in every aspect of our world. Our world is currently only hitting the high notes of sustainability culture. We have local government pickup for recycle at home, and we recycle some of these materials. Where's the disconnect happening? Is the marketing and information on recycling, is it the marketing and information on recycling? How much are we really recycling and how much are we not recycling and why? Without proper regulation, education, and adoption of sustainability as we are doing it today will cause our efforts to stall and become less buzzworthy. Company bottom lines will suffer and we will still bring harm to ourselves and the planet we call home. Recently, I had a magazine who wanted our input for an article. They kept referring to sustainability as a trend. This kind of bothered me a little bit. To me, bell-bottom jeans in the 70s was a trend that peaked and died. It's not a trend, but a disease of ignorance that kills very slowly. You can ignore the warning signs, but sooner or later, if we do not do something, the consequences will be far greater and possibly tip us over the edge of no return. Change happens with education, company transparency, and an informed consumer. When discussing glass, plastic, and biopolymers and paper, how do we easily determine which is best? To help us through the journey, we need to look at 4 main criteria to make this a little easier and break down this giant pile into manageable piles. The first one is the material recycled currently? What are the raw materials used to make each and how does it impact our planet? What form of conversion or manufacturing process is being utilized? And what are the properties of each material, including its specific gravity or weight? With that, we'll jump into glass. If I ask you what is glass made from, I assume many of you would automatically reply sand. But there's a lot of different kinds of sand. The problem is only one kind of sand can be used, and that's silica sand, or SiO2, by its chemical name. Sand and gravel are now the most extracted materials in the world, far exceeding fossil fuels. Simply put, we're on a path that we started with fossil fuels and have moved to the same tactics used for mining and depletion of these resources. From a sustainability standpoint, glass is an excellent material for recycling and is made from natural resources, much like fossil fuel. The issue is how we use it the first time, and do we set ourselves up to have a circular product lifespan? We are not only using silica sand at an unsustainable rate, but we are also destroying our environment just getting to the sand. I've got a picture here. This is in Brisbane, Australia in 2010, back when they were mining for sand. We're not only using silica sand at an unsustainable rate, but we're also destroying our environment just getting to the sand. The next pictures I'm going to show you are between 1995 and 2013, just a matter of 18 years. These two pictures are a river and lake just outside of Shanghai, China. Comparing the images from 95 to 2013, the agency showed how miners had widened channels, stripped the riverbanks, and dredged formerly shallow basins. Glass recycling in the U.S. has become broken and fragmented industry with local laws varying from state to state. If you look at the data above from 2000 to 2017, the world generated approximately 71 million tons of glass, but we only recycled about 18 million tons. Why did we only recycle about 25% of the glass we generated? States are cutting or canceling recycle pickup or significantly reducing what they will recycle. The recent ban from China has caused a domino effect all over the world. The University of Georgia has estimated that China's ban on imported recyclables will leave 111 million metric tons of trash from around the world with nowhere to go by 2030. But is it their fault? As an example, Little Rock, North Little Rock, and Sherwood in Arkansas, working together through the Regional Recycling and Waste Reduction District, they just signed a new contract with Waste Management that raises rates but as well eliminates glass starting as of April 2019. In addition, Polk County, which is between Orlando and Tampa, cite China officials as a reason for eliminating glass, magazines, and certain plastics from their local recycling program. What is an issue here is not China's fault. What it shows is we never really invested in real recycling. We invested in preparing and shipping our waste to someone else and making it easier for us. Ever wonder why people in general get away with just putting unrecyclable materials into the recycle bin? Our system was designed to not care and push the problem to someone else who now says, we've had enough. Glass manufacturers do prefer to use good quality cullet or recycled glass during their process. With the restrictions being placed on what is allowed and or canceling recycling, the level of quality of cullet has dropped significantly, as well as the amount available. At the same time, the price for recycled glass has gone up. The need is there not only by the converters, but as well by the customers and consumers of these goods. Glass is the only material we will discuss that is recycled by color as well. These colors are recyclable: amber, clear, green, and light pink. On the other hand, opal and any other color or mirrored glass is not recycled. One of the great things about glass is that it can be recycled basically endlessly with no loss in properties, and using recycled glass for new bottles or jars reduces the converter's carbon footprint tremendously. Glass has a high specific gravity when compared to plastic, paper, or bioresins, which equates to it being relatively heavier. Glass is also very strong. As a general rule of thumb, materials in general that are strong in one characteristic are usually very weak in an opposing material property. Glass is so strong in regards to flex modulus that in turn has low impact resistance. In other words, it is fragile and can shatter very easily because the material is so unflexible. Things to be considered when looking at glass. Glass in general must travel long distances from the factory of origin to the buyer, thus the weight and distance seriously cause a problem in reducing carbon emissions. Glass requires an enormous amount of energy to convert. Glass has a melting point of 2,700 degrees Fahrenheit. The energy used per container to convert is actually higher than aluminum or plastic. Aluminum melts at approximately 1,220 degrees Fahrenheit, and plastic in general is below 700 degrees. Just like paper and plastic, glass is made from Earth's resources, but for glass to fully decompose back into the different elements it was made from takes about 1 million years. Number 4, since glass is fragile, how much extra packaging do you need to transport it during its different stages to lower the risk of breakage? And lastly, number 5, the risk of dropping or breaking the glass when used by your customer also needs to be considered from a safety standpoint. With that, let's move into paper. Paper is one of the most recycled and oldest forms of materials we are discussing today. Paper was invented in China approximately 105 AD, and paper is derived from cellulose fibers harvested from trees in a virgin format. Paper has had a dramatic increase in recycling over time. The biggest increase happened in the 90s, where the recycling rate of paper increased to almost double. Paper cannot be endlessly recycled like glass due to the fact that cellulose fibers break or are cut and become too short to make new paper. Paper, though, is the quickest to break down out of all the materials we're discussing, with a time requiring only about 2 to 5 months. Where we start to run into some problems with sustainability is a lot of paper today is coated with plastic or wax. They can be separated if recycled, but drastically changes the rate at which paper decomposes as well. As an example, a paper milk carton is coated with plastic, and instead of a matter of months, it'll now take about 5 years to break down and still leaves the plastic behind to biodegrade over a much longer period of time. When looking at paper packages, ask if the paper has been approved by one of these agencies: the Forest Stewardship Council, Sustainable Forestry Initiative, American Tree Farm System, or the Program for the Endorsement of Forest Certification. These agencies help ensure that the trees harvested are done in a sustainable manner. Tree farms reduce our carbon footprint, whereas forests in general only consume the carbon emitted by the forest. So it shows the difference between tree farm and cutting down natural forests. This actually happens in a real circular and sustainable environment. The dead and decaying vegetation gives off carbon dioxide at a rate even with what about trees consume in that forest. Paper recycling also has reached record levels and has increased their stewardship by using just about every part of the tree when first manufactured. As an example, the bark can be used as fuel for different processes of the conversion. Recycled paper uses less water than the manufacturer of new virgin paper. Contamination of the water has been decreased also over virgin processing of paper. Paper creates the most CO2 when first manufactured and at the end of life. Methane gas given off by landfills is dramatically increased when paper is present. Recycling agencies are cutting off communities from recycling paper or dramatically decreasing what they will accept. Out of the 4 material groups we are discussing, it is a good thing paper does degrade in such a quick time. There's a really good site if you guys ever want to check it out. It's www.wastedive.com, and they've got some nice features built in there with filtered lists available to see what states have banned certain recycling programs across the USA. And you'll find and be amazed at how many states are banning different paper recycling programs. Within the packaging industry, paper coated with plastic is very common. This is done for certain reasons. It's done to protect the paper from damage, but also protect the bulk or what's in the package. Without the coating, a bulk can easily leach inks or other substances which have an adverse effect on the bulk and product. Paper, from a packaging standpoint, provides a canvas for a wide variety of decoration, although due to paper's flexibility, it can be folded, crimped, and shaped into various shapes. As you can see with the compact in the picture, it literally encompasses every corner, every radius. So that is something you cannot do with plastics in general. Paper does have flaws in its ability to incorporate different features such as closing mechanisms or threads. For an example, many of the paper compacts must incorporate either magnets or rubber elastic to keep the lid closed. Also, the mirrors are glued in and can cause issues with recycling, as well as the magnets. Considerations for paper. Ensure the paper you are using is sustainably sourced. Consider the end use of the product and the features that you'll need and require. Consider the expected life of a paper product versus another form. Decoration of the paper can be done with non-petroleum-based inks, such as soy-based inks as well. Biopolymers. Recently, biopolymers have been getting a lot of marketing hype due to increased attention on sustainability. If you pay attention, especially with biopolymers, you will see many of the same faults that other materials have when it comes to sustainability. The name itself generates interest from people looking for sustainable solutions. Here's an example of some of the names out there. And please do not assume that the companies I'm naming have a bad reputation or they have a bad product. That is not what I am saying. What I am trying to do is make you look and see how the name affects how you feel, think, and perceive a product due to the company name or the product name. First one, Earth Visions. Second one, Green Dot, EcoPure, NatureWorks, EcoVia Biopolymers. They all induce the feeling of sustainability, green, good. They make you automatically go, wow, this is what I've been looking for all along for my application. Where there's a lot of confusion is the definition of biodegradable and compostable. Biodegradable is a substance or object capable of being decomposed by bacteria or a living organism. Definition for compostable is a mixture of various decaying organic substances such as dead leaves, manure used for fertilizing soil. It's kind of hard to see the difference and seems basically the same, when in fact they're very different. Remember, all things are biodegradable, given enough time. Even oil-based plastic, glass, nuclear waste, all will eventually be broken down. The problem is the amount of time versus the rate of use, which is not sustainable. Compostable and industrial compostable are different than biodegradable due to the fact composting is describing an event under certain conditions that will more rapidly increase the biodegradable process. You see the difference? When it comes to composting, we need to be aware that if you're one of the few people who have a compost in your backyard, that these are very different compared to your local municipality industrial compost pickup. Industrial compost deploy various scientific methods of decomposing the waste at an accelerated rate versus your normal backyard compost. Biopolymers out of the four main material topics is the one category that needs attention placed on the words the manufacturers use. Not only does the name lead to many common misconceptions, but some companies try to mislead by using language such as bio-based, biological, and earth-friendly in their marketing. Despite the rapid growth, biopolymers and biodegradable plastics have not received much attention with regards to waste stream economic analysis. Biopolymers make up less than 1% of the global plastics market and are only expected to grow 2 to 3% in the next decade. In general, the public has a misconception that all biopolymers are plastics that can be just thrown in the trash and they'll magically disappear either in a landfill or their backyard for that matter. This totally diminishes the efforts being put into properly recycling them. In fact, most biopolymers do not decompose spontaneously under a natural environment, but instead require specific conditions such as an industrial composting facility. One must also consider that not all biopolymers are compostable. Biopolymers are typically based from natural resources or a fossil fuel origin. Biopolymers can be made from natural raw materials such as canola oil or sugarcane. The process to produce bioresins is sustainable, but may or may not be compostable. This makes it very complex and costly to properly manage biopolymer recycling or waste streams because they are not all created equal. We must also consider not all bio-based polymers are 100% made from bio-based sources. Some are actually made from petroleum-based components or a combination of the two. Properties of bio-based materials typically are similar to petroleum-based resins, and you will see no real change of performance. Many bio-based polymers are tailored to a customer, and there are not numerous stock grades available. And due to the size of the industry, a biopolymer many times is custom formulated for a specific project. One of the other things I wanted to do was bring up about specific gravity, as I talked about in the very beginning, and I've got an example here. And the specific gravity of PLA and PHA and type materials is approximately 1.24 for PLA, and PHA is around 1.3. So besides the cost per pound increase, you need to compare the weight difference cost when compared to PP. Because there is a difference not only cost per pound, but also in the weight of your product. So if we look at this example, to make it simple and easy, I put the three different materials, the three different specific gravities, and I made all of them weigh the same, and for argument's sake, I made them all the same price. You'll see PLA over PP is 32% heavier, and PHA is, when compared to polypropylene, is 38% heavier. If the plastic part made from PP, the cost would at 90 cents, your cost would be about 25 cents. In PLA, that jumps to almost 33, and in PHA, it goes to about 34 cents. This is only an example on waste versus cost. I'm not implying bio-based materials are too heavy to use, but as with all the materials we're discussing today, it is a balance of cost and your sustainable message. Another factor to take into consideration is supply. As stated, the supply side for materials is dependent on the number of producers, the land available to be dedicated to supply of feedstock and materials. So when it comes to land, let's look what it takes to make 1 ton of material from various feedstocks. So if we look at the two of the most popular feedstocks, corn and sugarcane, when it comes to land use, the chart is best case scenario and does not represent all feedstocks for biopolymers. What we can derive from this is we should have enough land available. The issue we are seeing is, once again, regulation and restricting have not caught up due to deforestation to plant more crops. We've already seen this take place in Brazil recently due to the tariffs imposed on soybeans. Brazil saw a tremendous increase in demand for soybeans and started cutting down more forests for more soy meat planting. Another issue is transportation of the feedstocks. The land used is not close to a port, and a major fight is broken out between the growers and the people fighting to stop deforestation. Has increased even more so due to the proposed new rail line, which will require even more trees to be cut down. Once again, balance. So we must remember as a people and their governments, we collectively need to look at all aspects of sustainability, not just the name of the material or which one makes us feel better. Considerations for bioresin. Number one, consider where your product may be sold and do. They provide readily available solutions for depositing bio-based resins for recycle or industrial composting. In other words, where you want to sell it, do they actually have recycling programs for bioresins in that area? Look at what stock material options are available, as well as the number of pounds available in your area. Make sure you understand what kind of bio-based polymer you are buying. There are grades which are combined with petroleum-based materials as well. Is it biodegradable, bio-based, or compostable? They are not all one and the same. So let's move on to plastics. Plastics have gotten a bad rap for some good reasons and some for not so good reasons. The one thing people seem to forget is that all thermoplastics are recyclable, but only about 9% of what we make is actually recycled. Sadly, there have only been about 7 true recycle codes for plastics. Even though there are hundreds of variations of polymers, many materials fall under number 7, which to the recycling industry equates to landfill, not the path of recycling the material. As with other materials discussed, our local municipalities and federal level government have not done enough when it comes to how we recycle any material. How many times have you seen the extra local blue or green bin meant for recycling goods have bags of trash that contain food items which are not recycled? The average American thinks they will sort it out for me, and because their normal trash can is full, they toss it in the recycle bin. Generally, misinformed consumers have not only driven up the cost to recycle, but have also lessened what is recycled. We're approaching our local recycling like we have our resources we should be recycling. This shows up especially in our plastic recycling programs and the low percentage of plastic we recycle. Of the 9% recycled worldwide, 30% of this is PET. And as another one, let's look at number 5, which is polypropylene. It's only about 3% of the 9%. So not only are we recycling plastics at a low rate, we're mainly recycling 1 or 2 of these materials listed. And one of the other things that people need to watch out for is 1, 2, 3, 4, 5, and 6 are not negotiable. And just to give you an example, polystyrene, number 6, a lot of people try and shove ABS or SAN into number 6. ABS is acrylonitrile butadiene styrene. Because it says styrene, they want to shove it into number 6. SAN is styrene acrylonitrile. The first word in its name is styrene, but it does not fall into number 6. It falls into number 7. Plastic is beneficial to reducing carbon emissions in one way compared to glass, metal, or paper. It's due to its very high strength to weight ratio and conversion cost. One of the most common questions I am asked about recycled materials, especially plastic, are they FDA? To explain this, let's ask the question, was the material FDA approved in its previously converted 100% virgin form? So I'm not talking about the pellets, I'm talking about the plastic part that was made from virgin plastic. Is it FDA approved because they used FDA approved resin? The answer is no. They are not automatically FDA approved for food contact after the material has been converted. Materials that are submitted and approved by the FDA are for their form in which they were presented. The plastic pellets prior to conversion are FDA approved. So in other words, once the bag is opened, FDA is no longer, technically it's FDA's starting point, but it is not an FDA approved part. So why are the parts made from FDA approved materials not FDA approved? There are too many variables that can affect the FDA status of a material, such as the colorant, process control, additives added by the converter, and so on, that is either not present in the initial material or it is closely monitored and tested. For example, a plastic part utilized in a hip or knee replacement is not FDA approved because it was made from FDA approved plastic. Physical reprocessing of materials where it is ground or pulverized is first sorted for color, foreign contaminants, washed, repelletized, or converted back into flake. Recyclers must show that contaminant levels in the repurposed material have low enough levels. Typically, recyclers will use a third-party lab for reassurance and testing, not only for properties, but also for food contact. Unlike the manufacturer of virgin material, recyclable materials present recyclers with a unique problem that their source of materials will critically affect the likelihood of passing third-party testing. Control of the stream to ensure there is no commingling of non-FDA and FDA-approved type materials just doesn't happen. What needs to also be considered is the FDA food contact ratings have different conditions. There's high temperature heat sterilized, boiling water sterilized, hot fill or pasteurized below 150, room temperature, refrigerated storage, frozen or refrigerated storage where the foods are intended to be reheated in a container at the same time of use. So not only is it not FDA, which rating do you fall under for your particular part? That's where using an outside lab for testing purposes helps ensure the converter actually is utilizing the correct material for their client. APC Packaging has invested considerable time ensuring each lot is tested by a third-party lab such as SGS or Intertech to test the lot for food contact and properties. With the PET recycle stream is overtly skewed to bottle for drinks. On the other hand, PP recycle market can range from clarified polypropylene for cups to car batteries to a baby seat. This affects not only the quality, color, and properties, but also can affect the cost as well. For this reason, I've listed many of the things that need to be considered and investigated when deciding on a recycle supplier or vendor that has recycle for conversion. 1. Ask what is the stream of recycle mainly derived from. PP toys, batteries, food containers, etc. Inspect the actual facility and see what and how they sort, wash, and extrude the material. Do they float sort, NIR or IR scan, or a combination of the methods? How many times do they wash the material prior to recycling? How do they handle the contaminated water from washing the resin? Do they pre-blend and post-blend the material? Do they test every lot in-house? Do they run a vented extruder to pull off volatiles? Do they run the materials through a screen pack to remove as many contaminants, such as carbon or aluminum flakes? Do they use a third-party lab for verification? And lastly, buy based on polymer type and publish spec for the PCR plastic supplier. So what I'm saying there is you want someone that buys the material based on the type and a published spec along with 1 through 10. For clear PCR materials, it's critical to understand that many of these materials are clear but have tints added to them. Most common is a slight blue cast that is given to PET water bottles. PET water bottles have been getting thinner, which makes this blue cast seem even less apparent. As an example, I've put 3 preforms up here. The first one is 100% virgin preform. The second is 50% virgin with 50% PCR. The third is 100% PCR. And what I want to point out is the difference between 50 and 100 is basically nil. The difference between no PCR with PCR is substantial. And where this comes into play is most PET has a tint involved when they first manufacture it, and more tint is added to the PCR. Well, in a bottle where the wall thicknesses have gotten anything but thinner, plastics for injection molding and utilizing PET, this becomes a problem because the wall stocks become thicker. The picture shows you a good example. That's only at 3 millimeters. If you think of a jar, a thick wall jar at 6 millimeters, it more than doubles. The other thing too is also consider that resins such as ABS, which are not on the list of recycled material, are also offered in PCR. Recyclers have seen a jump in sales over the last 5 or 6 years, and ABS PCR is available now in most countries. Clear materials such as PETG, PCTA, PCTG, SAN are typically not recycled due to complications within the PCR stream, as well as they all fall under the number 7. With plastics and recycling, attention also needs to be given to the form which the final product will be made. Plastics are divided into 2 categories, which are rigid and flexible, and affects what is and is not recycled by material recovery services. The next 2 slides will show us some examples. The next slide is all items that are not recycled. So you got everything from like saran wrap, DOs, styrofoam, flexible packaging like bags. The bags, like shopping bags, they're not being recycled by the recycling management systems, but a lot of chain stores have started recycle programs for the bags. On the top, all your bottles, your PET, polyethylene bottles, the PP caps, those are all recycled. The aluminum cans, but also yogurt cups and like clamshells are recyclable, but you need to check with your local service to see if they actually do take them. Excuse me. Plastic molding is also known for its ability to duplicate tight tolerances when compared to glass or paper. This is not only due to the process, but the materials as well. Introducing more variables will in fact result in some flaws that normally would never be acceptable if molded with all virgin materials. As an example, our stream of PCR PP is derived mostly from clarified polypropylene. Clarified PP is typically a copolymer polypropylene. Copolymer propylene is known for its impact resistance and low flex modulus. This has resulted in some long draw parts that cannot be 100% PCR. Due to the fact that it is a copolymer PCR, it's a little more flexible, a little more soft than virgin material, And when injecting a long part off a steel core, you can get a mushrooming effect or like an accordion type effect to the part due to the resistance created when pushing the part out of the mold. This one, this has to do with plastics because there's some that are out there. It's not bioresins. They call them bioadditives for petroleum-based plastics. I want to warn you guys to please read all the words on these additives. They tend to be very misleading. What they do is they mix a little bit of honesty in with false claims. So if you look at claim 1, the world is suffering from a food shortage. Sure, some places are. Using land to grow plants for bioresin takes away precious land and resources from farming food crops. Totally untrue. Claim 2, organic additive, when added at such a low percentage of total weight, makes any plastic item biodegradable in the landfill or the ocean in 1 to 10 years. Sounds great, right? When plastic biodegrades, it does not just break the plastic down into microplastics like most products do. It turns into a mixture of raw natural materials that becomes organically rich soil or nutrients in the ocean. I'm sorry, that is not true. So you do need to make sure these claims are vetted out, and a lot of times the easiest way to vet it is just read the brochure. Considerations for PCR. Have you inspected to ensure the PCR source meets your needs? Is your package categorized as rigid or flexible? What is the actual percentage of PCR in the entire package? Color can vary more over multiple lots, so a range should be agreed upon. PCR will have contaminants such as black specks at some point, so a range should be discussed and agreed upon as well. Next, I wanted to talk about refillable very quickly. I know I'm running out of time, and I apologize. Refillable packaging has started gaining ground within the skincare and colors cosmetics industry. Why is refillable a sustainable option? First and foremost, it reduces the entire package from a single-use package when empty by extending the life of many of the components to multiple uses. So instead of a disposable culture, it slows the process down to increase the sustainability. The refill culture has already been tested on consumers by non-beauty brands. Many of the items you already purchased. As an example, I've put up here Windex. Windex, if they were reselling, if they introduced refills years ago, and they even show in their marketing, one refill bottle is worth 3 trigger sprayer bottles. Businesses that have already entered the refillable market would have discontinued selling refills if the consumer wasn't buying into the value of refills. If the sales of refills were cannibalizing the normal saleable package, you would see shelf space increase for refills and saleable package decrease. This has not been the case. In general, you do not see people using the refills as the main package either. A good understanding of your client's needs, not only for the protection of the bulk, but their concerns surrounding refills being the first product purchase, as well as the client wants and needs surrounding sustainability, can be incorporated with good design. As an example, I just cut and pasted into the slide here. You can see I typed Google refillable airless bottles, and look what pops up. These are everyday, regular airless bottles that have been around for 10 years, and what people are doing is they're saying, oh, it's refillable, because the pump assembly unscrews from the bottle. This is exactly the reason we've been seeing a growing movement of sustainable products grow, not only with the newest generation, but older ones as well. Ignorance is not being accepted by consumers, and they're calling out obvious exploits, trying to brand something as sustainable through reuse. And years, I took a airless package and I just named some of the components that what people are calling refillable. So you've got the bottle and the pump assembly. The bottle is typically one of those three materials. The bottle pistons, polyethylene. Then you have a bottom cap or base, which is typically the same as the bottle. Then you have the pump assembly, which is ABS and polypropylene mixture. What the problem is here is there's no good design intent being utilized for this bottle. Because a consumer buys this as a refillable, the major portion, 80% of what the consumer is now throwing away is the bottle, which is made from components that are not recycled. So inevitably, we're still contributing, and the majority of the package is still single-use landfill. What I got here next is, this is one of our new refillable airless systems. As an example, the package can either be a refillable or just a regular airless package, all PP with up to 3 different button styles. PCR content can be up to 75% of the entire package, not one component, but the entire package. It's got a good-looking design that is relatable to customers. It's not funky or weird looking where people wonder what it is. It's also intuitive with a design where it's got a push to release, simply unscrew it and drops back in, and one pump, it locks the pump right back into the main bottle. Sustainable decoration needs to be considered also. How does this affect our recyclability of the material you choose for decorating glass or plastic? Sustainable application. I'm referring to how is the decoration technique applied. An example would be a paint line not having proper filtration, not only for the protection of those around them, but also to ensure that we're not releasing harmful chemicals into our air. Decoration materials that can be utilized, such as silkscreen ink, can be switched to soy-based inks or UV curable inks. UV curable inks are more sustainable than radiant cured inks. This is due to the fact that they release 0 HAPs, 0 VOCs, and cure instantly versus taking a long time to cure them with a considerable amount of energy used to create the radiant heat. I do get a question a lot about vacuum metallizing, and I'll have to admit vacuum metallizing has a history of contaminating the environment, but the question I get asked is, will it stop a product from being recycled? That's a little bit of a loaded question because it depends on where. Typically, the recycling process, the volatiles that are given off from the UV top coat that's applied after the aluminum has been applied burns off and is extracted through the vented extruder, and any aluminum pieces a lot of times are caught in the filter pack at the end of the extrusion line. But this does not mean that all locations and all people will accept it. Hot stamping, on the other hand, which is also aluminum being applied, is typically sustainable from our opinion due to the fact that it's a targeted application, such as a logo or a name only, not an entire package covered in hot stamp foil. For some of you, this may be entirely new information, and others know some or all of discussed today. What we do see is a need for education, sharing of information, and collaboration. We strongly believe this is each brand's journey, and our role is not deciding what is sustainability for that brand, but educate when needed and listen so we can provide real solutions. The road to sustainability can be confusing when there are so many details to be considered. The real question surrounding sustainability
Is it better to start imperfectly or not at all? I'll let you guys answer that question. So, let's take a look at the poll and bring up number 1. Are sustainability and climate change basically the same thing? Looks like we had 16% said yes and 84% said no. And like I said, I'm not going to say yes or no bad, but you can kind of derive from there which one is probably correct. Next is the second question. Which of these materials is more sustainable than the others? It looks like overwhelmingly most people pick glass, plastic at 8, bio at 11, and paper at 31. On this one, I'll let you guys decide based off of the information I gave you. If you still feel the same way, great. If not, maybe you guys are willing to look at a different form. So I want to tell everybody I appreciate your time, and I'm going to take a look at the questions that were submitted during the webinar. And don't forget to visit my monthly blog at techcenter.apcpackaging.com. And let's see. Curious as to why aluminum packaging wasn't mentioned. It's highly recycled. Something like 85% of its mined from the 50s is still being used. The mining process, blah, 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 blah. I didn't approach aluminum because not only due to the time, and I had a really hard time keeping within the time limit I was given, so that's mainly why. Aluminum is very recyclable. There are issues with the sustainability that needs to be addressed, just like the other ones. What about acrylic jars? Where does PMMA fall on the sustainable scale? Well, if we recycled it, it would fall into being sustainable. Problem is, we don't recycle it. It falls under number 7. I got another question here. I know PPE can be recycled, but from a recycling system standpoint, is it actually widely recycled? I think I answered that earlier when I gave the statistics about how much plastic is recycled worldwide, and PET was the major portion, and polypropylene, I think from memory, was only about 2%. Is there a good reason? No. Polypropylene, just like PET, can be recycled at the same rate, if not greater. Are frosted plastics not recyclable? If you're referring to a plastic part that has been has a spray coating on it to make it look matte, yes, it's recyclable. During the recycle process, it would be sorted, ground, washed, and where the coating comes into effect is when they extrude the material. That UV top coat or matte spray is being burned off and is actually being vacuumed out using a vented extruder. Let's see. Oh, somebody wants to know the website. That was, let me see here. I think it's Dumpster Dive, if I remember correctly. Was it under? Sorry, guys, I'm looking.
I'm sorry, I can't find it, but it was, I think it was Waste Dive or dumpsterdive.com. If you Google that, you'll probably be able to find it. Can you make replaceable cartridge? I assume we're talking about refillable out of biodegradable material or bioresin. Yes, that can be done. What needs to be balanced is the recyclability in the low-calorie areas that your product will be sold. As I had mentioned, there isn't a lot of knowledge in the consumer side to know what's compostable, not compostable, what has to be industrial compostable versus some bioresins cannot be done in a backyard compost. They have to be done at an industrial compost facility. So yes, but utilizing polypropylene or another recycled material, especially along utilizing PCR, that's probably the easier of the two, but the bioresin definitely can be done as well. Let's see, I think that's about it. Well, I just want to tell everybody I appreciate their time, and we'll close out here and end the webinar. And feel free to email APC Packaging if you have any other questions, and let us know. Thank you.